Okay, so question 2, we've got a 120 Newton weight. And I use the word weight very specifically here. It's not a mass, it's a weight or a force. And it's acting downwards on the left-hand side. And we've got some unknown weight acting downwards on the right-hand side. And it seems that the lever is balanced. So we need to find out the value of the unknown weight or force that's acting on the lever. So to do this, we use the law of the lever, which says the sum of the anti-clockwise torques is going to be equal to the sum of the clockwise torques. And that letter T, or tau, is the word for torque, okay, just like we mentioned, is torque, or a turning effect, also known as a moment. Okay? So the moments on the left are equal to the moments on the right. It's another way of saying it. So we've only got one turning effect. We know that the torque, or the moment is the force times the distance. So we call this one F1, this one would be D1, and then this one would be D2, and this one X would be F2. So we know that F1 times D1 is going to be equal to F2 times D2. Okay, so now we can put in some numbers. I've got my equation. I know I have 120 newtons on the left, or anti-clockwise, heading in the anti-clockwise direction, heading down this way, and in the clockwise direction. That's the other side, so our distance is 0.5 meters. On the right-hand side, or in the clockwise direction, the force is unknown, so I'll leave that as x. The distance is 1.2 meters. And that gives me, on the left-hand side, is 60 Newton meters, 0.5 times 120, equal to 1.2 meters times the unknown value x. So now what I have to do is divide both sides by 1.2 meters. That one cancels with this one, and that leaves me with the unknown force, or the unknown weight, equal to 60 divided by 1.2. And of course, if you follow the units, the meters cancels with the meters, and that leaves me with 50 newtons on this side, on the right-hand side. So we know that x is equal to 50 newtons. Okay, so again, just to sum up, what you're doing is setting the moments on the left, or the anti-clockwise moments, equal to the clockwise moments, or another way of saying that is the anti-clockwise torques is equal to the clockwise torques once the lever is balanced, because this is the law of the lever. Add them up, and then add up your moments on the left, add up your moments on the right, and then solve for whatever is unknown.